This is Dr. Emma Cliffe from University of Bath, who's been ploughing this for quite a few years and is excellent in this area. Her PhD was actually in number theory, I looked up last night, so
yes.
she's one of my own. So I'd leave it to Emma now to talk with getting started with accessible maths.
Good afternoon, also to those on Zoom. So this was billed as a session in which you might do something on your laptop. There's not going to be a specific part of the time when you do that. You're welcome at any moment to decide to do something with anything I'm saying, but all of these will be live online. So you can take the tiny URL down. That will take you to these live slides, which are also available in different formats, and you will be able to play with anything going into the future. I know there are some people in the room who know as much about this as I do, and they're very welcome to spend the time doing whatever they want. So the type of accessibility I'm talking about here is the practical and the technical. So we've been hearing about maths anxiety and different kinds of access. So I'm going to be talking about making resources accessible to someone who might need to work with that information in a different way than you work with that information. So I'm going to cover some areas. Why worry about it? What are the problems and solutions? And these are problems which are specific to mathematical notation. And then how do you get started in moving on from wherever you might be in your practice? So why worry about maths access? Well, we need to worry about accessibility of electronic resources, full stop. And there are laws covering this. And maths resources, maths documents are the same as any other documents. It's just going to be tougher to do the work. So the laws which cover this fall into two types. There are laws about equal access in England, Scotland, Wales, for instance, the Equality Act, or in Ireland, the Equal Status Acts, and in Northern Ireland, the, as amended in Northern Ireland, Disability Discrimination Act 1995. And those mean that we might need to do something specific for an individual who presents, who says, I can't use your lecture slides, I need them in this format. And then there are some newer laws called the Accessible Web Content Laws. They are interestingly named. In the UK, the Public Sector Bodies Websites and Mobile Applications Number 2 Accessibility Regulations 2018. And in Ireland, the European Union Accessibility of Websites and Mobile Applications of Public Sector Bodies Regulations 2020. They really roll off the tongue. So they are considered to cover content on a university virtual learning environment. And what this means is, regardless of the learner who may present themselves to you, anything you put on the VLE needs to be accessible, technically accessible, regardless of whether technical accessibility is what's needed. So both of those are going to come up throughout this talk, because what you need to do in both of those situations is a bit different, actually. The links there link you to the actual laws. I wouldn't read them. There is some guidance documents, but really, I'm not a lawyer. You should seek advice locally in your institution about what you're expected to do. But we should care anyway, right? So maths at university level is, and this is from the mathematics subject benchmark, characterised by the need for a high degree of conceptual and abstract thinking within the learning process. So we want students to have processing capacity to do that, to engage with concepts, to engage with abstract thinking. But a student with a print disability who is struggling to engage with anything you provide, or with difficulties taking notes for themselves in class, or have memory or concentration difficulties, are going to be spending substantial amounts of their processing capacity on entirely other things. So we should care anyway that someone can access the information in a way that works for them. So what are the problems? So generally speaking, as I was alluded to this morning, we need to make it possible to access and consume information in a variety of ways, to meet a variety of ways that people best consume information. So all students, but especially those with perhaps dyslexia or other forms of neurodiversity, will benefit from colourful, interactive, responsive resources with well-rendered maths and graphics, with video, with audio. Go for it, right? But if you make these in certain ways, they can create practical and technical barriers. So if we have complex navigation, or you need to give input to something on the web, that can be difficult if the user only uses the keyboard or only uses the mouse to interact with the computer or some other pointing device. The maths needs to somehow be chunkable and navigable for speech, magnification, braille, or if you're just on a small screen, have you ever tried to read a PDF with a lot of heavy-duty maths notation in it on your phone screen? You're trying to zoom in, but the formula's going off each side. So we need to be aware of that. Use of colour only to give meaning is a problem. Raster graphics are a problem when we try and magnify. They don't zoom well, they pixelate. And if we have responsive web pages with multiple things going on simultaneously, that can be hard for a visually impaired user. And maths in PDF is inaccessible. Now this video I'm not going to play because we established earlier that the sound is too low in the room, but you can have a look at it in your own time. I'm going to show you instead what I mean by that. If we magnify, if we reflow a PDF with mathematical notation in, it will destroy the structure of the mathematics. And that's because portable document format does not encode within it the connection between the numerator and the denominator of a fraction. There's no idea of the fractionness being there. It is visual placement of symbols in space on the original rendering of the page. So when we try and reflow it, it disappears. And when a screen reader tries to read it, we get a similar mess that you can see in front of you. So that's what the video is showing. So we need, for assistive technology to work, or just someone using their phone to read some mathematics, to produce accessible mathematical materials that people can use with their technology in ways that work for them. And the reader needs to have assistive technology which works with that specific format of mathematical text. So the computer relies on structural integrity in the maths, in the format in which you build it. So PDF is inaccessible, print, handwriting, ebooks which use images of maths. The computer can't process them. It has no idea of the structure of the equation. So they're inaccessible and inflexible on small screens. They effectively are lossy formats for the mathematical content. On the other hand, we have formats which have that structural integrity, so Word, HTML-based formats, some of them, one form of ebook, EPUB 3. They do have the ability to encode that structure within the format so that the computer can use it when you reflow the text or when you use a screen reader. But not all of the assistive technology can access maths in all formats. So mentioned earlier, there was something called Census Access or Ali for, I think it's Brightspace here, but Ali also exists for Moodle and other virtual learning environments. And those exist to try and take a document in one format and transform it to another. None of those work for mathematical content. They also destroy the mathematical content. A screen reader might work with one format of mathematics, say Word, but not with another. So we're at a moment in time where you need a match between the assistive technology and the format in which you provide the resource. For instance, PowerPoint 365 is theoretically accessible, but nearly all assistive technology won't work with it, and it can't be transformed to any other format. So it's kind of useless to anyone right now, but theoretically accessible. So you'd meet the Public Bodies Act by providing it. And then we also have the fact that most mathematicians use specialist scientific document preparation systems such as LaTeX. And historically, these don't output those formats. They output PDF. Of course, the mathematicians are using those for a reason, and we'll come to that. So the mathematicians are using LaTeX. It produces PDF. So the question is, well, can we convert that LaTeX, that system the mathematician uses, to produce one of these structurally integral formats like HTML? And the problem we have is that LaTeX is a very complex system. It allows the mathematician that flexibility to produce the notation they need in effective ways. But that flexibility itself is a problem because only a subset of it can be converted to HTML or Word. And it's really easy to just kind of fall out of that convertible subset and have no idea why as a mathematics author. You add a package in, you change the order of the packages that you're using, you use a seemingly innocent command, and suddenly you're in a world where you can't convert to an accessible format, and the system gives you no feedback. So can we convert the mathematicians away from using LaTeX? Well, they're using it for a reason, right? I'm a mathematician. I did my PhD in number theory. It was written in LaTeX. I've spent my whole life creating resources in LaTeX. I understand why people are using it because the system enables the mathematician. It provides key features of scientific document preparation. And these features make things more complex for converting the mathematicians. We need to provide a world in which they can effectively produce their documents and in which they can produce them accessibly. Software at the moment is catching up, it's in flux. It's not an ideal world, and nothing new is easy to learn because of the complexity. But increasingly, we're at a time where mathematicians are exploring, are moving to different ways of creating documents. But what we're finding is that they need appropriate institutional infrastructure, support, workload, time allocation, and training. So we've been doing this at Bath for about 20 years. So it's 20 years since I first produced an accessible form of a mathematical document for a student who was blind. And back then, we created them for each individual student. We used an expert to do it. We had specialist systems. And 20 years later, I think it's probably the first year in which every lecturer in the maths department was doing that pretty much for themselves with a screen reader user in their lecture group, right, in second year, and that student not needing any additional support or anything made specially for them. So it takes time to get there as a department. What are we trying to convert to? So HTML using MathJax. I will show that in a moment. Word or PowerPoint using the inbuilt equation editor, or EPUB 3 using MathML. These are the technically accessible formats. And to meet the public body's requirement, you need to be producing one of these three formats. And you need to supply the course content spine in this format. So everything, basically, needs to be there in one of these formats if it's on your VLE to meet the law. Okay? However, is that enough? Well, no, because whichever one of those you pick right now, there's going to be students who that doesn't work for. Their assistive technology doesn't work, or they can't open it on their computer or their phone, or it's just not useful to the majority. If you produce EPUB 3, most students were like, I have no idea how to open this file. So we also need to supply PDF, even though it's technically inaccessible. And in fact, the majority of disabled students in our maths department pick ClearPrint PDF. What do I mean by ClearPrint? I mean something that looks a bit like this. It's still technically inaccessible, but it's what most of the students who would be considered to be covered under these laws will select at the moment. So we're in the business of providing multiple file formats. We're kind of doing what Census Access or ALI are trying to provide internally to the system, but we're having to do it for ourselves. So the mathematicians are being asked to do a bit more work here than everybody else, because for everybody else, the system does it for them. So ideals are great, but let's be pragmatic. We're being asked to do more work, and that's fine, but I speak from a context where we don't ask any of them to do more work without providing the support and infrastructure to do that and a backup. So each individual lecturer assesses where they are, and we have a plan for meeting individual needs for equal access. That plan includes staff whose job it is to do that, who know how to use the tools and to provide the specific individual formats if necessary. As I said, we've been doing this for 20 years, and this semester one lecturer used that backup plan. If we go back 20 years, they all did. Okay. As an individual, pick something achievable to change in your general practice, in your provision, in meeting the Public Bodies Act. But what the leadership need to be doing here is to recognise that achievable depends on the resources provided to the mathematician in terms of the IT that's available on the computers so that you can do these tasks at all, and in terms of the time that you are given to do it. So your leadership needs to understand that this is a whole institution response, not on the individual lecturer. And then start. What we want to do is be clear to students in the interim what is and isn't accessible and what to do when something doesn't meet their needs, have a plan for how to enact that and make sure that that plan works effectively. Okay. So let's have a look at some of the options. If you are a Word or PowerPoint user, your life right now is fairly simple. It's only been like that for a few years though. This is how quickly the technology changes. And our speaker from Microsoft earlier talked about Immersive Reader. Immersive Reader can read mathematics aloud. That's great. As long as you make the document accessible, and there is a link there to Microsoft guidance on how you make your Word documents accessible, and it has an accessibility checker. And that's great, except it won't assess the accessibility of the mathematics. You can make a completely accessible document with completely inaccessible maths in it. So you've got one extra step, which is to make sure that you write every single item of mathematical text using the inbuilt equation editor. If you are writing the variable x as opposed to some x in a word, you use the equation editor. If you're writing theta, you use the equation editor. If you're writing x squared, you use the equation editor. You don't ever use insert symbol. You never write superscripts, subscripts, fractions using font or style changes or any of those things. You never use an image of an equation. And then the way that you need to check that document is not using the accessibility checker, but using review and then read aloud, so checking that it is read aloud. There's a couple of links at the bottom there. One is to Accessible Mathematical Word Document Workshop Resources, which goes through that. And the other is for effective keyboard-only input of maths in Word, because I recognise if I'm telling you you've got to input all the maths using the equation editor, you might like to know how to type that as opposed to clicking. Okay. It is all completely typable now. You don't have to click at any point. If you do that, then for some assistive technology users, that will be an accessible format. However, some students will require an older type of accessible maths in the Word document. So that's because their assistive technology vendor, whoever built the assistive technology they use, be that a screen reader or something that a dyslexic student might use for text-to-speech, hasn't implemented the interface to Word that enables the maths part of the document to be read aloud correctly. So you may need, or the student may need, to use the math type transformation. You might wonder why we don't build the resource using math type in the first place. That's because we can convert from equation editor to math type format effectively with the press of one button, but we can't convert back the other way with one button. So as soon as you convert from equation editor to math type, you can't go back again. So you have to convert a copy of the document. Okay. So if you are not a mathematician or a mathematician that doesn't have a lot of maths in this set of lecture notes, then it may be that that's your working method of choice. If you choose PowerPoint, be careful. You may be faced with the situation of a student saying, my assistive technology doesn't work with this PowerPoint, I need it converted to a different format, but it's not convertible to any other format at the moment, including to Word. So PowerPoint is its own issue right now. But generally speaking, a mathematician wouldn't be using Word or PowerPoint. They would be using LaTeX. So this is when we get into the question of what do those guys do? So the second format where we've got technical accessibility is a web-based format. It needs to pass something called WCAG 2.1 level AA to meet the public sector bodies laws in both Ireland and the UK. That's testable, so again there's a link there to how you would test that. But that won't test whether the mathematics is accessible. For the mathematics to be accessible, it must be in the MathJax format. How do you know if it's MathJax? We can right-click, and if we get the MathJax menu, then it's accessible. So MathJax is a way of rendering mathematics in the web, which specifically enables navigation, it enables chunking, zoom, copy and paste, color, size, layout changes. It also has structural integrity, so text-to-speech, screen readers, and electronic braille can be produced directly from the MathJax. Some assistive technology providers have implemented that directly. If they have, that's great. Some of them haven't caught up yet. For those who haven't, there is a fallback built into MathJax for area-aware assistive technology. Don't worry if you don't know what that means, because it's not your job to know what that means. Assistive technology people will. Assistive technology providers without native support for MathJax and which are not area-aware are a problem, but they're not your problem. Okay. So there is a link down here which says experience this yourself. And this takes you to a page where it explains how you can use the inbuilt screen reader for Chrome to install it in Chrome and then to use it in a simple way. And there are extensive instructions there to both hear graphs aloud and to experience the maths being read aloud. So this is the most accessible format that we can probably get mathematicians to, but we need a way of getting there. We need a scientific document preparation system which allows us to get to that end point. Now, at Bath, we are not prescriptive. We will support the mathematicians use anything that works because it's about their individual practice of how they make their own documents. But two main approaches have kind of come out of the maths department at Bath. There are some rarer contenders, which I won't go into today. The two main approaches are stay in the world of LaTeX, put up with the fact that I might fall out of that convertible subset and learn how not to, or move to a different way of writing my documents, which gives me kind of safety rails around that. Okay? And that's a personal choice. And we are supporting both of those, and I'm going to show you what those look like today. So the first one is, let's try and convert the LaTeX. Now, as I said, we've got experts at Bath who provide this backup support, and we use tools which will work for a larger subset, but they can tell you nothing about why it's gone wrong. And the experts that we use learn how to recognise the problems, diagnose them, and kind of backtrack. We have tried using those with the lecturers. It doesn't work very well, so we don't recommend it. What the lecturers found have worked for them is a package called LWARP. So there is some hard work involved. The manual for LWARP, at the time I wrote this slide, which was a while ago, I have to say, ran to 1,237 pages. So there is some work to do. And also what happens depends on what you're trying to do in the LaTeX. So if you take an old LaTeX document with lots of preamble and lots of stuff going on that's very complex, it might not work. You might have to kind of break it down and add stuff back in and keep checking that it works all the way through. You also have to work all this out yourself and then test it for accessibility yourself. So there are some downsides here. But if you really want to stay in the world of LaTeX, it seems to be the best way of doing so. So, let's see if we can wait for this to load. So I've taken a rather boring LaTeX document, and eventually when we get there, so I'm running LaTeX rather oddly inside RStudio. I'm not going to go into why, but let's just hide that. So I have some LaTeX. It's a fairly standard document, but one thing you will notice if you are a LaTeX user is it doesn't have a lot in the preamble. So it's got a short preamble. I'm not loading a lot of packages, and it's a short document. Okay. For those of you who have never seen LaTeX before, this is how mathematicians write maths. So let's find a bit of maths. And this is why we use document preparation systems as opposed to something like Word. So what am I doing to move to LWARP? Well, first of all, I could just compile the standard PDF. And this is what this will create. So we've got some actual maths there. Sorry, I will. Is that opened in Zoom? Yep. That's what this document will create. I don't want to do that. Are we back there again? Yep. Okay. So I've got LWARP there. Now, when I first just put use package LWARP in, I've already compiled the PDF, and then what I do in order to get my output format is, let's see where we are. So I have a command called LWARP MK, or make, and I ask it to just make the HTML. I've got some images in there, so I also need to make the images. So I've produced HTML, but is it MathJax? No. Okay. So I need to do more than just that. So instead of just use package LWARP, I'm going to need to tell it that I want to use MathJax. Compile the PDF again, which we don't want. And then back to LWARP make HTML. And then the images again. Now, I do have MathJax, but my macro is turned up in red. So that means I'm going to need not just to have my LaTeX version of the macro, but I also need to tell MathJax about that macro. Oh dear. Which I seem to have done something wrong. Oh dear, LWARP doesn't like that. Ah, that's why. And now my macro is there too. So with a simple document, I can get that far. There are other things that I can do which I've left in there. So this example is downloadable for you to have a play with. You can break a longer document into parts, so it will form a website. And you can have contents at the side. If you read the manual, there is a lot more that you can do. However, there are some issues. When I first did this, I had 2 packages loaded nearer the top. So it did not like this. So hyperf being loaded before LWARP gives me an error. Okay. So that was nice. It told me. With graphic X, there was no error. But when I try and then produce the HTML, I get one of the usually informative LaTeX issues, which is telling me that it has no idea what this thing is that I haven't included anywhere in my document. And it was only because I can read it and know that GIN, G-I-N, is something to do with the graphics X package that I knew that that meant I needed to switch the order of my preamble round. So this is what I mean by it's fine, but, okay? So build your document up one step at a time, compiling to HTML each time, and so that the moment that something goes wrong, you are more likely to work out what that is, okay? So that is what it looks like in a very basic example of using LWARP. Now, the lecturers at Bath who chose to stick with LWARP tended to be those who are very comfortable in LaTeX. They use a lot of additional tooling. They have multiple different versions of their lecture notes. They've got their problem sheets all kind of linked in as a big build. They've got with and without solutions. They've got a whole bunch of scripts. They've probably written a package in LaTeX at some point as well. They stuck with LaTeX and they went in the LWARP direction. Most of the other lecturers didn't. They chose instead, I think for their own sanity, to move to a Markdown format. Okay? So Markdown is a language designed for transform to HTML, to a web format. So it has guide rails. It's going to be really much harder to fall out of the transform. And the R part stands for R, as in the language R. But really, what we're talking about here is mathematicians, statisticians originally, wanting to include mathematical notation. So we have a transform from a simple markup language plus the LaTeX just for the equations for the mathematics. We're confined to a transformable subset. We've got a quick compile loop and a supportive graphical user interface. And because you're compiling to the HTML, not to the PDF as the normal thing, you will notice when something goes wrong. The typesetting is still as extensible as you need it as a mathematician. It's just more reasonably so. And so for most people, it worked out absolutely fine. There is a link there to a workshop on using R as a basis for writing an accessible mathematical document, which you can follow in your own time. And I will quickly show you what that looks like. So we still have a preamble type thing. It's telling the document how to compile. I can still put LaTeX-y-like packages in. The package family, to an extent, is available. And the type of things I'm typing can still make sections. I can make links. And I've got mathematics in here, which it will also preview for me. And up here, I'm in RStudio. I can knit to HTML, but also I can create PDF and also a Word document format. So I can produce those different formats that I might need to produce. And we can compile directly to a format which is accessible. Most of the lecturers at Bath have found that when they're starting from scratch on a new document, this is what they'll choose to use unless they are an expert LaTeX user and don't want to be deprived of that world. Okay. However, so R Markdown is great. You can produce a document like the one you just saw. But as a mathematician, you will very rapidly find that you want to do things like have a theorem in your notes. And you want to number a theorem and refer back to a theorem. This is not an unusual practice as a mathematician. And so at that point, you're going to want to move just above R Markdown to book down. So that's just built on top of R Markdown. It still works the same way in RStudio. You've got the same buttons there, except it was produced to make writing longer documents, basically. This was fine, except it wasn't fine when the pure mathematicians got hold of it. So the pure mathematicians, and actually their students, started to complain. And that's because in Bookdown, the way things are numbered is not very flexible. So the first pure mathematician to try this at Bath produced lecture notes, and the third year said, can you please number the theorems in a different way? And they looked at it and said, no, it turns out I can't. So we have built locally at Bath Claverton Down. It's called that because our campus is on Claverton Down. We might change its name at some point later. We've built Claverton Down for the pure mathematicians, and it provides additional functionality, both for them, but also it produces kind of the clear print formats, the large print formats as well. And we can do things like rename theorems. We can call them thoughts or nuggets or, you know, anything they want. They can also choose to number the different named things in one number sequence, which is surprisingly important for the pure mathematicians, though I'm on their side there. And we can use numbering in different ways. It's all about numbering, basically. Okay. So if you are a pure mathematician, you might want to move to Claverton Down. But there are other things that we have other than text and equations in a mathematical document. We might want to ask students questions and have them answer them. Now, the modern way of doing that, Maths e-assessment. You may be happy to learn, if you are a Numbas user or a Stack user, that both of those aim to meet WCAG 2.1 AA, the magic thing. There are probably others out there, but they're not ones that we use at Bath, so I don't know. So what you're looking for when you're deciding about procurement as a leader, what's happening in your university is, does it meet this standard? We want to include graphs and other images. Now, I'll get to diagram description ultimately in a moment, but you're going to find it much easier if you can produce a born accessible interactive graphic. So this is Desmos, and this is when I'm going to annoy people by turning Chromevox on, if I can find it.
4.9 simple. 4.9 simple. List with Experience. Desmos graphing calculator application. Graph paper. X-axis visible from -10 to 10. Y-axis visible from -4.28 to 4.28. Grid lines are visible. 1. Audio traceable curve. Press Alt plus T for audio trace. Image. Audio trace on. Use arrow keys to navigate. To hear the graph, press H. To disable audio trace, press Alt plus T. Expression 10. Audio trace off.
I'm now going to turn
RStudio
Chromevox
Pro.
off.
Tab. 4.9 simple graphs. Alert. Copy control extensions.
So Desmos was designed to be screen reader accessible. It conforms to WCAG 2.1. And you can actually move through that graph. You can find points of interest. And you can also, if you open it in Desmos, you can send a copy to a Braille embosser. So you have everything already there. The user can take charge of the graph. GeoGebra, for those who use it, also aims to meet the requirements. But just because you can make a usable, accessible object with a piece of software doesn't mean every object you make is usable and accessible. GeoGebra is a very flexible system, it's very powerful, and it's very, very easy to make something completely unusable. So we had a project between Bath and Coventry last summer called Beyond Alt Text, which looked at, okay, how do you make a GeoGebra thing which can actually be used? So again, that's a link. You can go and look at the guidelines that were come up with there. So it's possible, it's useful, but it requires time and care. For the statisticians, there is a package called Braille R, an R package. That is a project by and for blind statisticians who use R, and that will produce versions of things. Okay. So if we had a screen reader on, it would be reading out descriptions of what we're seeing, and we can move through a high visibility version of the histogram. And so it's not for the faint-hearted, I have to say, but there is a user group there, including the people who make it. For all other diagrams, I'm afraid right now the technology isn't there. So you're going to have to learn how to describe them. There is a Diagram Centre from Benetech, provides training in this, which includes scientific diagrams and mathematical diagrams. There's a webinar on complex image description. There are also guidelines from UCAF and NCAM. So again, those are links which you can use to get started. So what's your next step, right? This document is going to stay live on the web, and all those links out will take you to places that you could use as starting points. If you've never done this before, make your problem sheets using R Markdown. Start simple, okay? If you are a LaTeX user and you want to stick there, have a go using LWarp. Start with a small document, cut your preamble down, keep it clean and tidy. If you are an R user already, if you're a statistician, a natural thing to do would be to have a play with R Markdown, have a play with Bookdown. If you want to have a play with Chromevox, then there is a web page that does that, that again, you can play around with Desmos and listening to the equations. And if you're a Word user, open Word, write some text in an equation, get it read back to you. Start somewhere. Then think, what is the achievable step with the technology I have, with the time I have, in the infrastructure I'm working in? Change something for next academic year. So this document, as I said, will stay online. There is a group which is run by JISC Accessibility Community called the Accessibility Community Maths Working Group. So they've got a webpage, also a mailing list. That is now becoming the kind of the central point in which people are gathering. There used to be other groups, we're just focusing on that one. So if this is something you want to get into, then make contact with them. The Sigma network has an accessibility special interest group. We've moved away from overemphasis on the technical and practical, the things I'm talking about today. There is really an emphasis there on neurodiversity and affective issues now. So again, we're trying to keep the focus on the technical and practical in the JISC working group. I've got a website, Mathematics Accessibility MASH, which has got everything I've ever done linked off it. That's my email address, but my team knows as much as I do these days, so you can email them. Okay, I'm done.
Thank you very much, Emma, for an excellent talk. Very informative. Any questions for Emma? Comments?
Thank you, Emma. So at Bath, when your lecturers are converting documents either through a walk or books out, how do they take that HTML output and make it available to students?
Yeah. The slides that I produced, as you saw, there's a kind of link where you can download everything. So if you're using Bookdown or something like that, you'll produce something like this. You can zip up the entire folder. You put it, we use Moodle at BAT, it's on the VLE. You upload the zipped folder, you unzip it inside Moodle, you tell it which is the main file, which is index.html, and then the entire thing just lives within the virtual learning environment exactly like it looks here. They can download all the formats, because otherwise you get these long links of these are all of the different formats. Those who are using LWARP, they're only typically providing just the HTML and the PDF. Strictly speaking, they are able to get to Word using Pandoc, but they don't tend to do so unless it's requested of them. So they would send a Word file to the student who needed it, and they tend to just put the link to the PDF, and they put the HTML as a mini site inside Moodle. I don't know about other VLEs.
Hey, thanks for the talk. I've been looking at Stack for the last few years, just in the news. And I've started looking into JSX Graph because Stack is supporting that. I haven't read too much into the accessibility side of it, but I saw there was some development with like numbers and kind of coordination. Do you know, is that anywhere near as accessible as Desmos or plans or?
Yeah, it's not. No. And that's a shame. It was looked at by my team and we've decided to stay away from it right now. But we'll keep watching it. Chris might know more.
Not much more.
Okay.
Totally agree. I was just going to say that in numbers we've built sort of a wrapper on top of JSX Graph. Christian's built in some more accessibility, I think, by doing that.
Okay.
But I agree.
So there's people trying to fix it.
Fix it. It is one.
But it's not yet. But GeoGebra used to be not yet as well. So.
Okay, we'll just thank Emma again. Thanks a million, Emma.